Now, if you've watched my videos on finding equivalent fractions, as well as the video on reducing fractions, you've probably asked, okay, what is this all leading to? What am I building up to? Well, this is what you're building up to. This isn't all what you're building up to, but this is the next step. Adding and subtracting fractions. And I put that in parentheses because, well, you'll see at the end. Adding and subtracting fractions. 1/3 plus 1/3. Well, what does that equal? 1/3 plus 1/3. The first rule you need to know when you add fractions, you need to check out your denominators. Are these denominators alike? Meaning, are these denominators the exact same number? They sure are. They're both 3. There's nothing you need to do to these denominators. So, what I do is I just carry them over. You're not going to add the denominators. You're just going to carry the denominator over. Now you add the numerators. 1 plus 1 is 2. And it is as simple as that. When you have two denominators that are alike, also called like denominators, I'll just leave it at that, then that's the easiest sort of adding of fractions that you can do. And in parentheses, subtracting of fractions that you can do. Let's take it another one. 2/3 plus 1/3. First thing you do, check those denominators. Are these denominators alike? Yes, they are. They are both 3, so you don't change them. Now you're just adding across. So 2 plus 1 is 3. Now, as we know, any number over itself in a fraction automatically equals the whole number 1. So you would want to change that 3/3 into a 1. Oh, this one has 3 of them. So our denominators are still alike. And I keep using 3, but they could be 5, they could be 52. As long as they're alike, this rule applies. And these are alike denominators. So you just carry it over. Now you're going to add the numerators. 1 plus 1 plus 1 equals 3. And there we go again. You have to change that to 1 because any number over itself in a fraction equals the whole number 1. Now 2/5 plus 1/2. This is where I wouldn't call it tricky. To me, this is where it gets fun. I need to find multiples. Essentially, we're finding equivalent fractions. But the catch here is you need to find fractions, equivalent fractions, that share the same denominator. Well, how do you do that? Well, let's go back to our trusty multiples list. So as we know, times 1, times 2, times 3, times 4, times 5, times 6. We could keep going, but I don't think we'll need to. So let's fill it out. 2 times 1 is 2. 2 times 2 is 4. 2 times 3, 6. 2 times 4, 8. 2 times 5, 10. Oh, something just caught my eye. Let's go ahead and finish it out. 2 times 6 is 12. 5 times 1 is 5. 5 times 2 is 10. Wait. I just saw 10 up above. So what I'm looking for is the first number in the multiples, the first multiple essentially, that they share. That multiple is 10. Now, normally I'd want you to keep this work on your paper. However, go ahead and erase this. Remember that number 10. And now we're going to rewrite our problem. This is exactly how you want to rewrite it. Now, What we're looking for is how do we go from 5 to 10? 5 times what equals 10? We know 10 is a multiple of both 5 and 2. Now we just need to get there. 5 times 2 equals 10. So what you do on the bottom, you must do on the top. 2 times 2 is 4. Now how do you go from 2 to 10? 2 times what equals 10? 2 times 5. So what you do on your bottom, you have to do on the top. So 2 times 5 is 10. 1 times 5 is 5. So as we know, we've already got the denominator over here. That's not going to change. However, as we know, we need to just add across the top. 4 plus 5 equals 9. Our answer, 2/5 plus 1/2 equals 9/10. Circle your answer. Congratulations. Let's take a look at another one here. Remember how I put subtraction in parentheses? Well, this is why. It's the same process. The same process. So, we have two unlike denominators here. 8 and 4 are not alike. We can probably just eyeball this and see what the lowest common multiple is going to be, also called the LCM, the lowest common multiple. But let's go ahead and just work this out and see. So we know times 1, times 2, times 3. We probably don't even need to get to the 3, but we'll see. 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. 8 times 1 is 8. Do you think we can stop? We sure can. 8 is the LCM, the lowest common multiple, that both 4 and 8 share. So, remember 8, because that is our new denominator. Set the problem up exactly as you see it, only with the 8 as the denominator. Now normally we could just take that 3/8 and we could drop it right down, but I want to show you why and how. 8, how do you go from 8 to 8 in the denominator? Well, pretty simple. Just multiply by 1. And what you do on the bottom, you have to do on the top. So 3 times 1 is 3. So again, I could just say, if the denominator stays the same with one of those fractions in the problem, you just simply drop it down. But this is why. You're still multiplying it out. Now, how do you go from 4 to 8? 4 times what equals 8? 4 times 2. So what you do on the bottom, you have to do on the top. 1 times 2 is 2. And here we go. We already have our denominators set right here. We've just carried them on over. Now we need to just subtract these two. So 3 minus 2 is 1. So we can say that 3/8 minus 1/4 is 1/8. And I just want to point out, adding and subtracting, these are equivalent fractions, 1/4 and 2/8. You want to know why we had to learn equivalent fractions and reducing fractions? Because when you start to manipulate fractions using the operations like subtraction and addition and multiplying and dividing, you need to know how to find those equivalent fractions. They come into play, they come in handy. Good luck.